our instant freeze experiment. And just a word of warning, sometimes this doesn't work every time, and there's good reason for that. So don't get disappointed if it doesn't work on your first try. It's worth trying again. And that's because it depends where you put the drink in the freezer. It might freeze quicker if it's at the top as opposed to the bottom. If your freezer's quite full, it tends to freeze quicker. If it's quite empty, then sometimes it takes a bit longer to freeze. And sometimes as well, like now, it's been sat here for a minute while I talk to you, that might affect things too. So don't be disappointed, but I'm going to give this a go first. So I've done 3 different drinks here, so I can have 3 different goes. And you can use any type of drink. And at this point, your drink should have been in the freezer for about 3¼ hours. So 3 hours and 15 minutes is, I'm told, the ideal time. And what I did before as well is I shook them up quite a lot to get all of the gas at the top so you could see it getting really fizzy. So what I'm told we need to do, so I'm going to do this with Iron Brew, this is experiment 1, is you open the cap. Okay, and that's what I've done there, is I've let a bit of the, oh, it's working. I can see it already. I don't know if you can see, but ice crystals have been starting to form. So I opened the top and then I'm going to flip it over. Oh, it worked. And now I've got an instant slushy. And to show you that, what I'm going to do is I'm going to pour it into this glass. I'm so glad this worked. Oh, I've got a towel. It might be a good idea that you have a towel too, actually. And what I'm going to do is I'm going to pour it in here. You can see the ice crystals at the top. Now, can you see that? And I've got an instant slushy. Right, I might have a go and see if one of these will work too now too. So I might try the Dr. Pepper. This time, I don't know if this is going to work, but the way that this works is that the ice crystals are starting to form when the drink has been in the freezer. And this is what we called, it's in a hyper-cooled state at the moment. So it's really close to freezing, but it's not quite there yet. And you might have seen when water starts to freeze, it usually freezes in a really ordered form. And so that's why sometimes you might see ice, oh gosh, what's the name for those? When ice forms on your windowsill and it comes down like this, that's because the ice crystals are forming in an order. So it goes into a specific shape. If we left this in the freezer, what would happen is the ice crystals would form at the top and then they would eventually just go all the way down the drink and then they would become a solid block. But what we're doing here is we're making it freeze quickly. It's really close and there's a few ice crystals in there, and the sudden motion of shaking it then makes all the ice crystals form really quickly, and that's why it instantly freezes. I'm going to try something else. This time I've got a metal lid here. You could use a metal bowl, and this one I've put in the freezer too, so it's quite cold. And what I'm hoping is going to happen is if I really gently open this, because remember, if you move it too much, it might freeze. So if I open it really gently, if I pour it quite quickly, it might instantly turn into slush on the pan lid. So let's see if this works. Oh, it did work. Can you see that? Oh, it's not very good to show you because it's a bit shallow, but it freezes like snow instead of like ice. And that's something that Joseph Priestley noticed, that when you have water, it freezes in a block, but because of the gas, the carbon dioxide in it, it freezes a bit more like snow. Oh, you can see it coming out there because it's expanding and it's getting too big. And here's my slushy. Oh, brilliant. I'm so glad that worked.